Welcome back to the Edgeverse TechCast, your show to learn more about NXP enablement. Speaking of enablement, this is day 2 of CRA week.
And I'm Bridget Stone. Yesterday we covered step 1, risk assessment, understanding what could go wrong and how to classify your product under the CRA.
And today we're moving on to step 2, where all those risks start shaping up into real engineering decisions.
This is where compliance moves from analysis into architecture. Step 2 is security by design.
And joining us today is Marc Vauclair, one of NXP's security experts, helping customers apply CRA principles in real product development. Marc, welcome to the CRA week.
Thanks for inviting our team to this series to clarify the development process with CRA. Step 2 is security by design. We have some great suggestions to help with this mindset. I'm a security fellow of the Competence Center for Cryptography and Security team. I'm based in Belgium. And in my free time, I'm never far from mathematics and technology, either teaching or reading books.
Oh, that's right. I remember you telling me all about your awakening to mathematics and the enchantment it brings you in your life. Well, hopefully the CRA will not require all of our listeners to have such a deep knowledge of mathematics, but I'm sure it's helped you with getting a better understanding of the details in CRA. So now let's jump into this CRA discussion, Marc.
Well, fortunately for our listeners and me, you don't need a PhD in cryptography to apply security by design, just the right mindset. So Marc, let's start with the basics. What does security by design actually mean, and why is it such a central path of the CRA?
Central part, say that again.
What did I say?
You said path.
Oh, and why is it such a central part of the CRA?
For product with security functionality, the security is either an afterthought, something that was included as an add-on, or it's there by design. There's no absolute security. Instead, we are talking about here managing risk. When you look at it from that perspective, security by design considerably reduces the risks involved in implementing security. Security as an add-on might have a higher risk, and in some cases, introduce additional unnecessary risk in the product. That's why it's important. The CRA translates security by design into specific, actionable requirements, often referred to as secure by default. First, products must be released in secure state, without known vulnerabilities. Next, security features must be enabled out of the box, without requiring users to configure complex, advanced settings. Next, inbuilt encryption and data minimization, only collecting the necessary data, are required for data protection and privacy. Next, components must be minimized and unused interfaces disabled to limit the entry points for the attackers, reducing the attack surface. And last but not least, the product must include mechanisms to ensure that only trusted software runs during startup, like secure boot and integrity.
So this isn't just philosophy. CRA translates security by design into concrete technical expectations. Secure boot, encryption, minimizing attack surface. These are all architectural decisions.
Yes, security by design under the CRA is not a one-time event. It covers the entire product lifecycle. Therefore, scenarios like managing vulnerabilities in general and applying updates are also part of the security by design exercise. That's why it's so important to speak about threat modeling and risk analysis. This is one of the most misunderstood parts of the CRA. The CRA in Article 13 says that you have to assess the security risks associated with your product. That risk assessment needs to be taken into account during all of the phases of the product lifecycle, starting from the point of time before you start defining your product. It's there to minimize the cybersecurity risk over the course of the product's life This is not just another box to tick to comply with the regulation. It is something that makes your compliance with the CRA a lot easier.
And this absolutely connects directly back to step one. Risk assessment drives everything that follows. Without understanding your risk, you can't design effective protection.
By the way, security by design is part of NXP's DNA. This is encoded in every secure product and applied across the company by means of our in-house edgelock assurance program and validated by independent third parties, certifying our secure development process against standards like IEC 62443-4-1, ISO 21434, ISO 15408, also known as Cromont criteria, and IEC 81001-5-1, among others.
Okay, well, that's quite a list, but now let's make this practical for our listeners. So once a manufacturer understands their risk, how do they begin applying security by design into their own development process?
You need to apply it at a very early stage of the product design. Based on a threat model, identify the adequate mitigation techniques and required security functionality by applying a risk assessment. Add those requirements to the rest of the product requirements, like dimensions, power consumption, and so on. And carry out the product development with milestones along the way, verifying if all is on track. By following this approach, manufacturers can reduce security risk on the final product, and compliance becomes largely an administrative procedure. A threat model is one of those fundamental ingredients for security by design.
So really, security just becomes part of the original requirements, as it always should have been. The engineers can avoid trying to patch it in later, as you mentioned, introducing probably security risks just by adding it in later. So the engineers can now start to address security just like they do for power consumption, performance, and cost, like you mentioned.
The key thing to understand about your risk assessment and your threat modeling exercises is that they are what allow you to minimize the amount of effort to secure your product. All of the essential security requirements and all the other things that you have to do might sound perhaps big, scary, burdensome, but they are also prefaced with language like based on the cybersecurity request at risk assessment. So they are all scoped to be limited to just having to do the right amount of security that your threat model and your risk assessment dictate as necessary. That's why getting it right and really understanding this stuff is so helpful. You will find that if you are too lax in your risk assessment, if it's not realistic, you might not comply with the CRA. That might constitute a false or misleading statements to the authorities, with the consequent penalties. If you are overly strict with it, you might find yourself spending way too much time and effort hardening a product that you know is not a defense system. It doesn't necessarily need to have the absolute state-of-the-art hyper-secure everything. It just has to be secure enough on the basis of an accurate and reasonable risk assessment.
So, Marc, what you're saying is that not every device needs Star Wars missile defense level security, but every device does need an appropriate level of security.
Yes, it provides some good context for why you should care about this stuff, why you should make sure that your engineers are performing risk assessments and threat models at the beginning of the development process.
Can you provide a customer example of these threat models that can help our listeners grasp this concept?
Yes, for sure. Threat modeling is a brainstorming exercise. One starts from the listing of all the assets related to the product that have to be protected in confidentiality, integrity, authenticity, and availability. These assets include as well what is a normal expected behavior of the product. The next step is to identify and classify all the threats. You also have to identify the kind of attackers that you are considering, ranging from hobbies to state organizations. depending on your use cases. Mitigations are considered based on the outputs of the threat modeling activities. The risk assessment will prioritize which mitigations should be implemented. Let's take, for example, a wireless computer keyboard. It's an input device interacting with a single user. When we now put a device in this context of potential threats, the trusted one-to-one interaction between a user and their keyboard is put in a new perspective, particularly wireless connectivity. It means that any other device could be used to interact with the keyboard connected to the user's PC. In this scenario, another device could potentially snoop or read data that was intended for the user's computer. A device could inject and write data onto the user's computer. An attacker can also flood the air with wireless messages aimed at the keyboard or the computer to prevent the communication between the keyboard and the computer. The capabilities to launch such an attack require a software-defined radio device, or SDR, together with some software for scanning devices and reverse engineering the connection protocols, and so forth.
That's a perfect example of how connectivity expands this attack surface, even for something perceived secure like a keyboard, and just why threat modeling is essential early in a design.
In this case, if you look at our example, reverse engineering is documented there, together with what was needed to attack the keyboard. The interception of data onto a device is also documented. It's not always obvious to look at your own product from an attacker's perspective. Keeping in mind this attacker's perspective, developers can build an attack model. This helps identifying where countermeasures and controls need to be implemented.
And once they complete this threat model, what is next in their step of security by design?
It's time to look at the basic elements of the risk assessments. The risk assessment takes as input a list of the threats. The threats need to be decomposed as much as possible to identify so-called risk factors that we can assign values and give them certain weight. One recommendation is to be asset-centric for each threat. We look at what is being impacted, what are the assets that are being lost. Is the loss of data, private keys, personal data, loss of functionality, service loss, or even loss of reputation? And what about non-tangible loss? Then, as a first approximation, priority is given to the most impactful events, the most impactful attacks. Threat intelligence helps identify if threat actors are on the attack model, if they are motivated or even capable of carrying out an attack. Furthermore, there's another element of the other risk factors to be considered, such as the severity of the vulnerabilities identified in the design. Overall, a risk assessment will combine different risk factors. Things that have weight, like probabilities of an attack. It will compute a risk level derived from a risk model formula, which needs to be revised per project.
Mark, can you apply this to your example of the hijacked keyboard?
Yes, with the keyboard example, spoofing is recognized as a class of threats where a person or device is impersonating. In order to avoid that, authentication is required. We've also seen tampering with data with our keyboard example. That's when data is being modified and the attacker has the potential to write data back. A fix for that would be an integrity check by cryptographic means. This, as input to a risk assessment, derivates on most security features that will be implemented using some form of cryptography.
All right, Mark, that was a great explanation. And I want to talk a little bit about implementation. What technologies does NXP provide to help customers apply the security by design?
Many. NXP has a large number of applicable technologies for different threats and risk scenarios. Some examples are functionality like encrypted install of the firmware, encrypted install of the keys, secure debug and configuration, remote key install for secure manufacturing and addressing vulnerabilities during the life cycle of the product. There are also functionalities for encryption of internal and external memory, different mechanisms for isolating data and code between secure and non-secure areas, serving as mechanisms to protect integrity of the device and its data. Connected edge devices require secure connectivity. NXP provides functionality that includes device origin attestation, secure communication, accelerated networking, and remote key management.
So these capabilities give manufacturers a strong foundation so they don't have to build security from scratch. They align directly with CRA requirements, helping customers implement protections efficiently and confidently.
Finally, addressing security by design implies to be ready to detect, respond, and recover from cyber incidents. For that purpose, measured boot, software attestation at runtime, cyber resilience recovery, tamper detection, and battery-backed monitoring are some of the key functionalities supporting those activities.
Great, Mark. You did a great job explaining just how security by design needs to be adopted by our customers who are listening to this episode. Moving forward, it's going to be critical for all customers to put security in their architectural phase of their products. So let's recap step 2 as you've outlined it. So first, integrating security from the beginning. After you do your risk assessment in step 1, you need to start putting security into your design processes. It can't be an afterthought because, as you mentioned, patching security almost immediately introduces other threat assessments. It has to be really a part of your core product architecture from the beginning.
Threat modeling helps you identify what needs protection, and risk assessment helps you prioritize. Secure design ensures your product is resilient from day one.
Mark, thanks again for helping us bring step 2 to life. We will add some of the resources in the episode notes. I'm sure the listeners will love to look into what helps you better understand CRA.
Thank you. It was really my pleasure.
And tomorrow we move into step 3, proving compliance, where we explain how manufacturers demonstrate that their product meets CRA requirements.
And if you enjoyed this episode, don't forget to subscribe and follow our CRA week as we release each step.
And until then, keep innovating,
keep designing securely, and we'll catch you on the next Edgeverse TechCast, which is tomorrow, CRA Step 3.